Mellin transform comes handy in such integrals. So in the integrals where basically we have some special functions and along with the log x. So in such integrals, and if it's from 0 to infinity, the Mellin transform can be helpful. Yeah, and since Mellin transform of most of the functions are well known, so that's why I'm using this. And I have also found in the previous video the Mellin transform of cosine integral function. Yeah, so basically if you don't know what cosine integral function, this is just minus integral from x to infinity of cos t by t dt. Yeah, and now in my previous video I found out the Mellin transform in the world of S. Basically, let's say Mellin transform in the world of S of ci of x. Yeah, and that came out to be, the previous video is in description, also it's linked over here, and the answer was minus gamma of s by s cos of pi s by 2. Yeah, so this is the Mellin transform that we will use. Now Mellin transform of function is just integral from 0 to infinity x to the power s minus 1 and then f of x dx. For a general function f of x, the Mellin transform is this integral. Over here the function is basically cosine integral function. Yeah, so that's why it will be ci of x dx. Yes, now we know that this is just minus gamma s by s cos of pi s by 2. Yeah, now if we differentiate both sides with respect to x, s, if we differentiate with respect to s, we get integral from 0 to infinity x to the power s minus 1 times ln of x and then ci of x dx. Yeah, if we differentiate this with respect to s, this will be the case because x is now a constant. Over here there are three things and we will use product rule. First of all, just minus 1 by s. Minus 1 by s is 1 by s square, and others as it is gamma of s cos of pi s by 2. Yeah, now plus minus 1 by s as it is, gamma of s is just gamma dash of s, its derivative is just cos its derivative minus sine pi s by 2 and then dot pi by 2. Yeah, plus now the integral of the other is minus 1 by s and then I differentiate both of them. Sorry, that's a mistake. Just differentiate just one term at a time. Yeah, this is actually a mistake. Gamma dash of s and then cos of pi s by 2. Now here's just a gamma of s and the derivative of the expression is minus sine pi s by 2. Yeah, and then we have pi by 2. Yes, okay, good. Now after this we have to substitute s as 1, so that this goes to x to the power 0 and this is 1, and so we have the required integral. So substitute s as 1, we get over here integral from 0 to infinity of ci of x times ln of x dx. Yeah. And on the other side this is just 1 times the other is gamma of 1. Yeah, and then we have cos pi by 2. Yeah, that is just 0, plus now this is minus 1 and then gamma dash of 1 cos of pi by 2 is just 0 again, plus this is minus 1 again gamma of 1, and now minus sine pi by 2 is minus 1 and then pi by 2. Yes, okay, now good. Now this is 0, this is 0, and this is minus is plus, so we just have pi by 2. Yeah, and that should be the answer. Let's see. Yeah, that's the answer. So it was easy because we knew the Mellin transform, and just use the Mellin transform integral and then differentiate it with respect to s. We get the log function and then substitute s as 1, and that gives us the answer. And yeah, I think yeah, that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.